Hi, I'm Jaden, here with Carnegie Mellon Solar Racing, to tell you about what we've prepared for this year's competition. But first, I'd like to touch upon last competition because there's some things of note that informed our decision making. These were the stability of our boat, how it sat in the water, and how the various subsystems interacted within our boat. But most importantly, two failures that had occurred in our propulsion system.
This is the CAD for the lower unit of a propulsion system, which we had fabricated and used during last competition. And this is a detailed drawing of the propeller shaft for that CAD. As you can see at the top, the propeller shaft is much thinner than it is throughout the rest of the shaft. And this is what led to our first failure in bending, which would have knocked us out of competition if it hadn't been for the generosity of the Cedarville team to allow us to use their shop and repair it, as you can see here. However, we ran into another issue, and that was with the shaft collar depicted here. The shaft collar was rubbing up against the back of the hub continuously throughout competition. And what went from looking like this, generally, ended up looking like this about halfway through competition. This is when we knew that we had a lot of work left to do on the system, and not just this system, but all of our systems in general.
So now that we've talked about the issues with last competition, we can go on and talk about the progress we've made since then. And in order to do that, I decided to interview our sub-team leads in hopes that clips from those interviews can provide insight to those watching.
So my main goal was essentially just to keep the boat working. Since we didn't have access to shop space due to COVID, it was really just doing research for the most part, looking at next year. Like, okay, what are the components that we can buy? What improvements can we make? What further things can we collect data from? More sensors. What things that should we be tracking? But for specifically this year, my main focus was just to okay, at the very least, can we make sure that the boat runs? But yeah, I guess most of my work was looking forward to the next year when we have time to really integrate all these new components and new things into the boat. Now I know a lot more about different ways we could track various things on the boat. So in particular, I'm gonna mention how do we track how fast the boat is going. Right, so a speedometer essentially. There's so many different methods, but I think all of them have some drawbacks. And it's interesting to see how you can combine them to really get the best possible measurement. So for example, you can use a GPS to track your position over time, and that will tell you the velocity, but then GPS sensor measurements aren't 100% accurate. So there's some leeway with that, but then there's things you can do to filter out bad data from that. And then you can use additional data from accelerometers, or maybe even how fast the motor itself is spinning, to really just hone in on those right values. So it's really interesting to see, or for me in particular, the research did educate me about a lot.
Over the past year, our main goal was to start the design of our own propulsion unit that we will manufacture in-house. And right now for competition, we are using a Torpedo system, which is one of the best systems that you can buy. But for our application, it's not the most efficient, especially for the endurance race, and due to the inability to change the gear ratio. So we started to design our own propulsion system. These are the possible drivetrains that we can have: the belt drive, bevel gear, retrofit, and the criteria as well, and their various weights. And what came up on top was the retrofit design, due to mostly because it's very efficient and it's very reliable as well. And here's a picture of it. So therefore, our main task this year is to connect the lower unit to the motor. And to do so, we did these calculations that related the motor torque and speed to the lower unit torque and speed. And while this, gives us a pretty good estimate on the gear ratio that we need between the two parts, I think the most important thing is to get the boat actually on the water to test and to test for the optimal gear ratio. And physically, to connect these parts, we are designing a adapter plate, as you can see here in the CAD.
I think we've been doing some really exciting stuff, like most of our other sub-teams. So we were forced to do remote work this year, like all of our campus was, but I think we made the most of it. We were planning to continue work on building a new hull, but unfortunately weren't able to meet in person. So what we decided to do instead is focus on designing a lot of the smaller areas of the hull that don't really get thought about a lot. This includes things just like attachments, jointery, the actual seat that people use. Historically, this has kind of been a struggle for us, but what we've done is just rip whatever is in the old boat out and put it into our new boat, and then come time for competition, like a week before, someone will try and make some improvements if they have time, but it leads to a very uncomfortable experience. But hopefully now that we have like a better seat design, a better design for the interface already, like materials are listed out, it's gone through a design review, all that needs to happen is it needs to be built. First I'll show off what we've been doing, what we all did last year, and then I'll show off some of the stuff that we did this year. So just a brief look at last year. What we spent most of the year doing was finishing up the design on our old hull, and then starting out the assembly on the new hull. And you can sort of see what our process looks like here. These are all of the cross sections of what our new hull would eventually look like. We build a carbon fiber hull, so our process goes from building the plug into creating a fiberglass mold into creating the actual carbon fiber boat. Everything we're doing here is in the mold stage, and you can see this is us in the progress of plastering and sanding everything together. And right now, here's what the boat looks like by itself. So nice, it's all shaped up. We just need to refinish it, put on and start the rest of the process, and you will hopefully be able to good to go next year with a entirely new boat.
So yeah, main goal I'd say was just to get something competition ready. I think for a while the Opti team has been falling short. So my main goal was to finally get something that could be run reliably. And so what that required from our team. So like I said, it was a lot of young freshmen. And so from them, what it required was just general interest. I tried my best to teach them what I could. And I guess hoping that they would, be interested enough to actually care about it and learn about it. And kind of go through the struggles of being on Zoom. Doing things like coding over Zoom isn't easy, but they stuck it out, which is good. And then specifically, so we have our old system. It's kind of always been based on the same idea. Like we've just been trying year after year to get battery monitoring nailed. We're just trying to either keep track of the amount of charge left in the batteries or the current voltage level of the batteries. Whatever it is, we essentially just want, that like smartphone equivalent of you have this percentage of battery left.
So hopefully those clips from our sub-team leads have given you a good idea of the progress that we've made in the past year. And to summarize, while we have put in a lot of time to get the boat ready for competition this year, it has been our focus to design and implement subsystems that will be used in future iterations of our boat in years to come. Once again, I'm Jaden, here with Carnegie Mellon Solar Racing, and I want to thank you all for taking the time to listen to our progress.